Hi, this is Mrs. Jackson. This is Chapter 3, Section 3, Part 3. In this video, I'm going to introduce to you how to divide one polynomial by another. And really the goal of doing that division is to rewrite that dividend as its factors. So we'll also practice that. Okay. Our first example, we have a dividend here. I'm going to label it. And we have a divisor. So I'm going to, oops, I forgot my arm. So I'm going to set up a long division just like we did with our numerical examples. The key thing to note though is that you want to have a place value for all of your variables. So in this case, our dividend has a cube, has a square, it has an x to the power of 1, and then a constant. If we were missing any one of those terms as we descend in exponents, we would put a little placeholder in there. Likewise with the divisor. We don't have that in this case, so I'm just going to go ahead and set this up as I would normally do in a numerical example. I'm going to put my dividend underneath the long division symbol, and I'm going to put my divisor outside here. Okay, so the first thing that we are trying to look at here, maybe I'm going to put it in yellow. I'm going to look at this first term in here. Think of it as a place value, x cubed. And I'm only going to look at this first term in the divisor, x squared. So I'm going to ask myself, how many times does x squared go into x cubed? In other words, what is x cubed divided by x squared? And the answer there is x. So x cubed divided by x squared is x, and I'm going to look at where that place value is here in my dividend, and it's right here, the x to the power of 1. So when I put my result here, x, I'm going to put it over that place value. Now, just as we did with numerical examples, I'm going to multiply this by my divisor, and this time I'm going to multiply the entire divisor. So x times x squared is going to give me x cubed, and since that's a cube, I'm going to put it under its like term. Next, I'm going to say x times negative 4x gives me negative 4x squared, so I'm going to put that under the x squared term. And finally, x times a positive 3, that's going to give me 3x, and I'm going to put that under its like term. Just like what we did with numerical examples, we would now subtract this, only this time we're subtracting a polynomial, an entire polynomial from another. And so as you recall in our addition and subtraction video, when we have this subtraction here in front of this entire polynomial, it has the effect of changing everyone's sign to its opposite, because it's like a negative 1 distributing to each term. So you can see here that the x cubed minus x cubed, these guys are going to cancel. Next, I have negative 6x squared minus a negative 4x squared. That's minusing a negative, which would be plus. So negative 6x squared plus 4x squared would be negative 2x squared. And then I have 11x minus 3x, which would give me 8x. All right. Just as we did with the numerical example, you're now going to bring down the next term. And I'm going to go ahead and do that division again. This time, I'm only looking at this negative 2x squared. So negative 2x squared divided by x squared is negative 2. So I'm going to put that, and that's a constant, so I'm going to put that above its like term. Negative 2 times this entire, so we're going to now do negative 2 times this entire polynomial. So negative 2 times x squared gives me negative 2x squared. Negative 2 times a negative 4x is a positive 8x. And negative 2 times a positive 3 is a negative 6. And I'm going to subtract this entire polynomial now from the one above it. Again, all the signs are going to change here. And when you actually find the result of that subtraction, you will see that our remainder is 0. And consequently, as we mentioned in a previous video, if our remainder is 0, then the quotient is a factor of the dividend. If our remainder is 0, then the divisor is a factor of the dividend. So the goal here is I could rewrite our division. You know what? I'm going to actually write this down as a reminder. The dividend equals the divisor times the quotient plus the remainder. I have to move over here. So if our remainder is 0, then the divisor and quotient are the factors. So I'm going to rewrite our dividend, x cubed minus 6x squared plus 11x minus 6 can be rewritten as the divisor, x squared minus 4x plus 3 times the quotient, which is x minus 2. And if you can spot it, this trinomial here, quadratic trinomial, this is factorable. So I won't go through all the steps to factor that, but many of you could probably already see that x squared minus 4x plus 3 is the same thing as x minus 3 times x minus 1. And so I'm doing this for purpose so that you can see where we're going in this chapter. This complex polynomial here, if it were a function, if we were trying to graph that as a function, y equals this polynomial, that polynomial can be rewritten as this, and we can see these would be x equals 3 would be one of the x-intercepts, x equals 1 would be an intercept, and x equals 2 would be an intercept. So with that information, we have a lot to go on how to graph that polynomial. Okay, let's take a look at an example where the remainder does not equal 0. So I have 16x to the power of 4 minus 85 as a dividend, and that's being divided by a divisor of 4x squared plus 9. And so this would be an example where we're going to need to put placeholders for every exponent, descending exponent in the dividend. And so when I rewrite this dividend, 16x to the 4, I'm going to write some place values, 0 times x cubed plus 0 times x squared plus 0 times x minus 85. So I need those placeholders in there in order to keep all of my terms lined up. Likewise, I'm going to rewrite the divisor, 4x squared plus 0x plus 9. All right, so again, we're only looking at this first term in both the dividend and the divisor. So 16x to the power of 4 divided by 4x squared. 16 divided by 4 is 4. And x to the 4th power divided by x squared is x squared. So I'm going to line that up over its like term, 4x squared. And now I'm going to start to do my multiplication. 4x squared is going to multiply the entire divisor. So 4x squared times 4x squared is 16x to the 4th, and I'm going to put that under its like term. 4x squared times 0x is going to be 0x cubed, and 4x squared times 9 is 36x squared, so I'm going to line that up underneath the x squared term. All right, now when I do my subtraction, the entire polynomial is being subtracted from the one above it. So I'm going to kind of capture that in parentheses. All right, you can see that the first two terms are canceling by design, and these two terms are also 0. Now I have 0x squared minus 36x squared is going to give me a negative 36x squared. And I'm going to bring down my next place value here, but it's really just a placeholder. And I'm only going to look at negative 36x squared divided by that 4x squared over here. All right, so negative 36x squared divided by positive 4x squared is going to give me a negative 9. And negative 9 is a constant, so I'm going to put that all the way over here, over its like term. Now I'm going to start to do my multiplication. Negative 9 times positive 4x squared is going to give me negative 36x squared. And negative 9 times 0 is 0. And negative 9 times a positive 9 is negative 81. And I'm going to subtract this whole thing. And so think of this as 0 here. And so we get our cancellations here. And I have 0 minus a negative 81 is going to give me positive 81. And I'm just going to bring down this negative 85 here. 81 minus 85 is a negative 4. So that is our remainder. So again, the goal here is to rewrite that dividend. So I can say that that dividend, 16x to the 4th power minus 85, equals the divisor, 4x squared plus 9, times the quotient, 4x squared minus 9, plus the remainder. So dividend equals divisor times the quotient plus the remainder. We haven't gone over all of our polynomial identities yet, but we could, for this is a difference of perfect squares, and so we could further break that down, and that would help us understand the graph of this polynomial. All right, so at first, division of polynomials looks a little complex, but we're going to be using the same techniques as numerical long division, and so we'll get a lot of practice with this. And I hope this video helps. Thanks for listening.